Okay, so this is 6.4a in elementary algebra called special factoring patterns, and I am out in my boat, out in the middle of the lake doing this lecture, so if you hear kind of weird sounds, there's probably seagulls or something, but anyway, not very comfortable out here, but I'm just sitting out here waiting, so I figure I'd get a lecture done. In this section, it's called special factoring patterns because there are some equations that you're going to get that have kind of a pattern about them that you don't have to actually do the whole factoring thing in order to solve these. You can just look at it, and because it's in a certain pattern, you can just quickly and easily come up with the answer. Now, you can do it the old way, even if there is a pattern, but it just gives you a chance to learn about some of the patterns in math, and that you can do these that way. So, for example, in Chapter 5, we had a problem like this, okay, and we squared it. And that meant that we did a plus b times a plus b. It's a little rocky out here, so my writing isn't real great. Okay, and the way that worked then is you did the FOIL method, and when you did the FOIL method, we got the first term squared plus the two terms multiplied and doubled, and then we got the last term squared. So when it was written like that, we would get an answer that looked like that. When we had something like this, that meant a minus b times a minus b. All right, and that worked the same way. Square the first term, square the second term, multiply the first times the second term, double that, put a minus, and put a plus. Okay, and that was just kind of the pattern that you learned as far as in order to solve an a plus b with the quantity squared, you'd get this, and when it was a minus b, the quantity squared, you'd get this. So you've got kind of that pattern there to figure those out. And we're going to kind of continue on with that, but what we're going to do is we're going to go from here, given a problem that looks like that, and go back to that. Okay? So if you have a problem that is that way, it will be this here. Okay, so for example, all right, looking at this, what I need to do is find out, are there two numbers I can multiply together that give me 25x squared? Well, two numbers multiplied together give me 25 is 5 times 5, and x times x is x squared. So they call it the root, the square root. What number multiplied together will give me that? So it's 5x. 5x times 5x is 25x squared. All right, what else do I know? Do I know two numbers multiplied together that give me 36? Yes, 6 does. Okay, so I've got those two numbers. Now I look and say, if I put these two numbers together and multiply them, and then double that, what do I get? So 5x times 6 is 30x. Now if I double that, I get my middle term right there. Okay, but when I double it, this is negative, so I have to double it and put a negative in front of the 2 so that I get negative 60x. So if all of those statements are true, if I can take this first number and get 5x out of it, take the 36 and get 6 out of it, and then take these two numbers and multiply them, and then double them, do I get that number? If I do get that number, then that is my answer. Okay? That is my answer. And what happens is your answer is going to be whatever you multiply to get this, whatever you multiply to get this sign right there. Okay? So what do you multiply to get that? What number can you multiply by itself to get 25x squared? 5x. What number can you multiply together to get 36? 6. Put a minus sign because there's a minus sign there, and you're done. Only if these two multiplied together and then doubled give you that middle term there. So if that's the case, then that ends up being the answer. So that's one of those shortcuts. And I know when you look at that, you're like, oh my gosh, are you kidding me? That doesn't look like much of a shortcut. It really is if you're trying to figure that problem out using the factoring that we've done before. So let's look at another one. Let's look at 5x squared plus 30x plus 45. Okay, the key thing when you do these, remember, the key thing that you want to always try first is factor. Is there anything I can factor out of that before I do anything? Well, yeah, I can factor a 5 out. And what am I left with? Okay, took a 5 out of there. All right, so now we're just looking at this. So, is there a number I can multiply by to get x squared? X times x is x squared. Is there a number I can multiply by itself to get 9? Yeah, 3 times 3 is 9. Now if I put those together and double those, do I get my middle term? Yes, I do. That means I can do that. And I'm done. Okay, so again, this sign right here is this sign, and don't forget to put a squared there. And that ends up being your answer. We took the 5 out, so it just kind of follows to the end like normal. But then we do that. Is there something we can multiply by itself to get x squared? Yes, x. Is there something we can multiply by itself to get 9? Yes, 3. So those are your two numbers. Now, if you can multiply those and get 3x and double it and get 6 like we did here, and that's what's here, then that's our answer, and you put a squared up there, and you're done. So the next pattern we're going to look at is called the difference of two squares. And what it looks like is if we have something like 16x squared minus 25. Okay? So we have two numbers, and there's a difference. There's a minus sign there. Okay? So there has to be a minus sign or it's not the difference of two squares. It does not work if that were a plus sign. So the question again that you're asking yourself, is there something I can multiply by itself to get 16? Yep. Is there a number I can multiply by itself and get 25? Yes. When that's the case, you put a plus sign, then you write the exact same thing with a minus sign, and you're done. Okay? That's all there is to that. It's always a plus, always a minus, same number in each spot there like that. Only if you can take, it's like I said before, it's called the square root. Only if I can take that number and find something I can multiply by itself to get that 16x squared, and only if I can find a number I can multiply by itself to get 25. And this too has to be a minus sign. Okay, so let's look at one more here for the difference of two squares. So I'm going to put in here 1 minus 36a squared. Alright, is there anything I can multiply by itself to give me 1? Yeah, 1. Is there anything I can multiply by itself to get 36? 6. And what about the a squared? Well, a times a is a squared. Plus, minus, you're done. Alright, let's keep pushing here. Let's jump up to example number 5. And we have 4x squared plus 16y squared. Okay, one of the things that you'll notice here is that we can do some factoring. We can factor out of 4, right? Okay, so there's our first start. Now remember, one of the key things I said is this sign here has to be a minus. It's not a minus, so we can't do anything else. We can't solve it any further. It's as simplified as it's going to go. But that does bring us to example 6. In example 6, we did one like this a while back, just like example 6, so let's go ahead and do this one. X to the 4th minus y to the 4th. Now, remember, this was all the things that we've been doing had to do with like x squares and y squares and stuff, but this is x to the 4th and y to the 4th. So remember what I said? We try to change these to an x squared and a y squared. So we do this. Now we have a squared there and a squared there. So what we have to do is we have to say, is there something we can multiply by itself to get x to the 4th? Well, x squared times x squared gives us x to the 4th, right? So we put that there. And what gives us y to the 4th? Y squared and y squared, right? Okay. That being the case, we put a plus sign there and a minus sign there, and we are done with that one. Alright, so let's see, what would be next? Example 7. In fact, I'm not going to be done yet, because I just saw something I wasn't thinking about. Right there is the difference of two squares. So actually, yes, that answer that I have here is correct, but it can go a little bit further here. We can't do anything with this because of that plus sign. But are there two letters, or is there something we can multiply by itself to give us x squared? Is there something we can multiply to give us y squared? And there's a minus there, so we put a plus and a minus there. So this right here is this simplified. We can't do anything with that. So this ends up being our entire answer. X squared plus y squared times the quantity x plus y times the quantity x minus y. So don't forget to keep going there like I almost did, and simplify everything you can as far as you can. And that brings us to example 7. Okay, so what we have here is we have this squared and this squared. So because of that 2, that means this is multiplied by itself. So two numbers multiplied by itself give us x minus 3 squared. Well, those two numbers multiplied by themselves are this and this. So that whole quantity is multiplied by itself in order to give me x minus 3 squared. Is there something I can multiply by itself to get 25? Yes, 5 and 5. So actually I get this being a minus, this being a plus. So our first term was this, and our second term was this. Our first term is that, our second term is that. So, before, when you'd have something like x squared minus 25, what two numbers multiplied together give you x, multiplied together give you 25, and we did this. Okay? Exact same thing as what we did here. The only difference is this was our x. I mean, this x minus 3, that is our quantity that we squared, just like our x was our quantity here that we squared. So it's just an x minus 3 instead of just an x. Now let's see if there's anything else we can do in there. We've got x minus 3 plus 5 and x minus 3 minus 5. If I take the parentheses off, and this gives me x plus 2, right? And this gives me x minus 8. So that ends up being my final answer. Okay, so I'm going to stop here with this video and continue on for just a few minutes on a next video on 6.4b. So this is 6.4a complete.